Hi, my name is Steve Rahi. I am a premier field engineer specializing in management technologies. Today's discussion will focus on ConfigMgr current branch, specifically the peer caching feature that is built in. A bit of an agenda as we get started. So, want to talk about what is peer caching? Most of us probably already know that, but we'll talk about it anyway. What is ConfigMgr peer caching specifically, and then why do we care about peer caching in ConfigMgr? Some of the requirements for setting up ConfigMgr peer caching, talk about a couple of scenarios briefly, then get into the demo part where we'll spend most of our time to talk about configuring peer caching in ConfigMgr, then see peer caching actually work in action in depth, and then wrap up talking about some troubleshooting, suggestions, tips, and tricks, and so forth. Okay, what is peer caching? So peer caching here, we're talking generic peer caching. This is not something yet specific to ConfigMgr, right? So peer caching in general is a mechanism to optimize network usage. It allows leveraging local content sources, peers, for content, right? So having peers on your same network region, as you define your network region, to pull content locally instead of going across the network. So content acquisition, big one. Pixie Boot. Now, Pixie Boot's interesting because this is something uniquely offered by third-party solutions at the time of this recording. Who knows what the future will hold, but right now, that is a third-party solution thing only, not a ConfigMgr thing right now. Peer caching defines groups of peers. The way you can do that, really two ways. You can either group by subnet, or you can group by boundary group. I'll call this out again in a minute. Subnets grouping is the way that third parties, as well as branch cache, will group peers. Boundary groups is the way that ConfigMgr groups peers. So we'll talk about that again in just a minute. I'll offer one more thing on that. And then whatever mechanism you use, whatever third party you use, the whole goal is to help reduce infrastructure, typically distribution points in an environment. So what is ConfigMgr peer caching? So ConfigMgr peer caching is no different. It allows potential peers that are defined by boundary group membership to act as local sources for obtaining content, right? And then the boundary group defines who all is participating within this group of peers that can pull content from the defined peers that are offering content. More about that will come clear in a minute. So ConfigMgr peer cache, when it was first introduced, an often asked question was, okay, does this replace branch cache, or does it replace third-party solutions? The answer is not at all. This is a solution that augments what other third-party solutions or even branch cache you might have in your environment. It does some things that are similar to these third-party solutions in branch cache. These third-party solutions and branch cache offer some differences as well. So you'd want to evaluate it all together. And again, not really viewed as a replacement scenario, more of an augmentation scenario alongside our third-party partners in our own product, branch cache. So ConfigMgr is native. ConfigMgr peer caching is native to ConfigMgr. It does support all content lookup scenarios. It does include OSD. It is currently, as of this recording, ConfigMgr current branch 1706 is the current iteration. As of this recording, peer caching for both OSD and content lookup outside OSD is in a pre-release status. Now, just a comment about pre-release status. Some folks are hesitant to enable pre-release components for the infrastructure, and I get that, right? Pre-release, unfortunately, had some wording with it earlier on that kind of inferred that it was not a scenario that would be fully supported in production. That's not true at all. Pre-release features are fully vetted, fully supported for production use. The difference is they just might be adding additional development at a pace more rapid than perhaps other things, right? And so don't be afraid of pre-release. In fact, you should get very familiar with pre-release features because they add a lot of really cool functionality. Think about another pre-release feature, the Cloud Management Gateway. If you look at its history from first it being introduced as a pre-release feature to finally being pulled out of the pre-release status, the core functionality of that component did not change the entire time. There were things put around it to help augment the administrator experience and give more controls and so on. That's kind of the example, right? The core functionality is not going to change. We're going to try to make things better for you to implement in your environment and make it even a more useful solution and so on. Okay, so why ConfigMgr peer caching? Well, just said it. It's native to the product. This is not an extra expense that you have to spend to get this feature. And so it's one of those things that I look at and think, why wouldn't we introduce this into a ConfigMgr environment? Does that mean that you might still need to use your third-party solutions to kind of augment around this? Sure, absolutely. There's absolutely no harm, no foul, though, to turning this on, getting experience with it, understanding what it will do, how it will do things that will help you make intelligent decisions about what you do in terms of direction for things like peer caching going forward, maybe focusing third parties in a certain other area of your network. Don't know, just calling out. Native to the product makes total sense to go ahead and use it. And like any peer caching solution, we have this in place to help reduce infrastructure footprint. There are some differences in the way ConfigMgr peer caching works compared to our third-party partners and even branch cache. We'll talk about that as we get further along. I'll briefly mention it here, and then we'll build on it a bit later. When you have peer caching in the environment, you won't necessarily always go to that peer, even if the peer has content, to get the content, right? The peer then becomes one of the available content sources that you can randomly pick from. Now, I'll asterisk that. I'll come back to that again in a bit. Decreasing content download time. If we can get it locally from our peer that is in our same boundary group with ConfigMgr, and since those boundary groups should respect network configuration and put similar systems on similar segments together and so on, or at least where you have fast connectivity, right? Then it will help you download content in a quicker amount of time. Right? So the question again, ConfigMgr peer caching, third-party solutions, which should I use? The answer could be, and sometimes is, yes, to both, right? It's just understanding the abilities, the capabilities, your network, how it fits in, those kind of things. But definitely take a look at it. Since it is native, it makes a lot of sense to look at. So what are the requirements for setting up ConfigMgr peer caching? We'll run through the list. We'll actually go and actually do the configuration here in a minute. So you do need to have domain joined systems, okay, in order to share content back and forth. Your boundaries, you need to have that. You don't see this, the boundary when called out so much in the docs, but truthfully, to make this work, you need to have boundaries properly configured. You need to have membership of your boundary groups, I should say, instead of boundaries, properly situated so at least one system in the boundary group is enabled to share content. And there's some pre-work you would want to do here. Look through the various systems that are available and decide which one or ones should be enabled for branch, for peer caching. I keep saying branch caching because we have a component called branch cache in Windows. So look at your systems in a boundary group and identify which one at least or multiples of systems should be enabled to participate as a content source peer, the one that will serve content to peer systems in that boundary group, right? So how do we enable that? Well, we go to client settings and we enable content sharing specifically for systems that will cache and then provide content to their peers in the same boundary group. Now, I mentioned think through which ones that should be. A few things to think through. These systems that are going to act as content source peers should be on all the time and available. They should have large amounts of disk space that are available to store content. They should have good connections available. So with the server OS, that can be unlimited. For a workstation OS, there are 20 connections typically inbound to a workstation OS at a given time. So factor that in when you were picking which one should actually be serving content. Another thing to consider, managing your cache size settings. So if you're going to be using a system to cache and then serve content, you'll definitely want to make sure that they have those systems have plenty of space to host that content. In the same area of client settings, you can configure increases to that content cache size selectively on those machines that you identify to act as content source peers. So one thing here, we ConfigMgr admins, including myself, maybe I'm just speaking to myself here, don't know, get into the habit of doing things that at first may not really be a bad thing at all, but down the road we realize, yeah, that's a bad habit. We need to break that bad habit and get out of it now. One of the things that I do all the time in my lab is I will go into the content folder, the cache folder, where content is downloaded, and if I want to force it to re-download, I'll just delete that content folder manually from the cache, right? And then next time I ask for it, it will error out in Software Center, but the second time it will come down, no problem, repopulate everything, and that's great. Until this, right? So if you do have a caching source peer that has content, as soon as that content arrives in the cache, there's notification sent forward to the management point and to ultimately the site server to say, this client now has the source and can offer it to others in the boundary group whenever asked, right? Well, that's great. If we go manually delete it by going into the cache, selecting the folder, and deleting it, that's going to cause problems, because when that deletion happens, there needs to be a notification that goes back to the MP and then ultimately back to the site to say, this content is no longer available on this content source peer, so no longer factor it in. All of this communication, you'll see in a minute, happens by state messages. So the point is, don't manually delete this stuff anymore by deleting the folders directly in the CCM cache. Again, talking to myself here as well. But use the client applet, as you'll see me do in a little bit, to delete that content, because that, or use the ADK, or SDK methods, I should say, to delete that content, because then we'll factor in all the work that needs to happen to clean it up and so forth, right? Enough about that. So network access account. So prior to 1706, a network access account was required in order to implement caching, pure caching, right? After 1706 or 1706 forward, we don't need it anymore at all, except whenever we're trying to pull content in Windows PE. Now, if you're in Windows PE and using that anyway, you're probably doing imaging, and so you should have a network access account configured anyway. This shouldn't be a big surprise, but it is a requirement. So what scenarios can we bring peer caching to bear to support? Well, pretty easy, right? Anything, really. Imaging, certainly standard imaging. You can pre-stage content as well to content source peers. One of the things that you see in the documentation that to me isn't really clear is that there's a discussion about how to enable the task sequence and so forth to bring down the content and then make it available to share. What is not really talked about is perhaps you don't want every one of your systems that are being imaged to be enabled as a content source peer to be able to share the content. So you may not want those systems to cache the content, because if they're never going to share it with anyone, why consume the disk space? We'll talk through that a little bit more as we get to an example, and that's one of the specific ones I want to do. And then standard deployments, right? So imaging and standard deployments, all of them are supported, no problem, and can pull content from the peer. All right. So let's work through our first demo, and that is to configure ConfigMgr peer caching. So let me pull in my lab environment. So here is my ConfigMgr site. All right, and the first place I want to stop, and again, this isn't really called out in the documentation, it kind of is inferred, is to stop in my boundary group configuration. Now this is my lab, and so my lab is very simple, and all I have is a single lab boundary group where all of my systems, a certain subnet, all of my systems are contained in this. Well, actually, I've reconfigured this so every single system in my lab is covered by this boundary group, which is fine, right? In terms of references, I only have my full distribution point in here. You do not have to place content source peers in this list, right? They will be discovered as part of being part of the boundary group and being able to serve content to peers and so forth, right? So there's no need to specifically configure them in this group. You do need to make sure that each boundary group contains at least one content source peer. Examine this. Look at the IPs or AD sites or whatever you're using to factor in what machines will be a part of each boundary group, and then make sure that at least one in that boundary group is enabled to support content source caching or peer sharing. Yeah. All right. So when you build your boundary groups, consider your network configuration. Know that there are some implications. Should be corner, right? But if you have a system that is part of a boundary group, think of the system as one that will act as just a standard client, wanting to reach out to a peer in that same boundary group to get content when that content's available. If that client roams and the recalculation of boundaries kind of is a little bit delayed or doesn't happen as it should, right? Then there could be a point in time at which this system that has roamed outside of the area in which that boundary group is defined, the networking area where that boundary group is defined, could still think it's part of that boundary group and ask for content from a peer in that boundary group across maybe a slow network link, like maybe they're a hotel room now or whatever. Should be a corner scenario. Could happen. Just be aware of that, right? And our boundary recalculation should largely prevent that, but it is something to be aware of. All right, so that's boundary groups. What about enabling peer caching? So first, let's go to client settings. Okay, and again, I kind of don't like the phrase enable peer caching. Peer caching is something that happens regardless. You don't have to tell the clients, go get content or try to get content from a peer. No, it doesn't even really happen at the client level, right? You'll see this in the logs. Let me explain. So every client will, whenever that client needs content, whether it be imaging content or whether that client needs just content for a standard deployment, every client will go to the management point, make a location request, that hasn't changed, and then receive back from the management point a list of sources, traditional distribution points, pull distribution points, whatever, that have that content, then we'll randomly select which one to go to from that list. So there's really no component on the client that specifically says, I'm part of a peer, I'm in this boundary group, I have peer caching enabled, so now give me a list of systems that will be my peers and have content because I've somehow magically turned on peer caching. No, the enabling of peer caching is something that turns specific clients on in the subnet or in the boundary group to be able to offer their content to peers in the boundary group. So now when the peers in the boundary group go and make a location request, the ones that have been enabled to share their source have already told the management point and opened the database, hey, I'm here, I have the content, I can share it. And so when that standard location request goes up, the returned list of potential sources for that content include this content sourcing peer that happens to be in the same boundary group, right? A lot of words there to try to illustrate the concept. Hope it made sense, and you'll see this happen in just a minute. So when we go into client settings, you see I have a specific custom client setting to enable peer caching. This enables peer caching for which systems in the boundary group will act to serve their content to their peers, right? So I just go into properties of this custom client setting. And look, so this is where you turn it on, turn it off. So all of our cache management settings are here. Also the ability to turn on the ability of a config manager client in full OS to share content. This will make this client what's called, you'll see it in the logs, a super peer, right? It is a peer above the other peers because it has content to share, okay? You configure the maximum cache size as a percentage of disk here, or in megabytes, make sure you get the value you want by making sure there's the right value is implemented, right? 20% might not allow you to reach 50,000 if you really want 50,000. In some cases, by disk size, whatever. Here's where you configure the ports that you can use with peers talking to each other to obtain content and so forth, whether you want to enable SSL to make that work, right? And since this is built into Config Manager, this client setting, whenever you enable the client setting, it will automatically configure exclusion rules in Windows Firewall if indeed you have Windows Firewall enabled for protecting clients, right? But this is where it's all done. So you'll hit OK here, you'll save this out, and then you will deploy it. Now, really good idea to build a collection of systems that are going to be your content source peers in the environment. So you can have one collection across the entire environment of all content source peers. The membership of this collection will include systems across all of the different boundary groups that you're trying to enable for peer caching, and then target this policy at this collection to cause those systems to enable for being a super peer or a content source peer that can then offer their content to other clients in the environment. All right, so that's setting up the ability to enable peer caching. Right now, let's put a pause there. That's for any standard deployment. As soon as you do this, and as soon as the content's downloaded to a peer that is enabled as a super peer, as a content source peer, then all the other machines that are looking for that content will be able to factor in that content source peer, that super peer, as a potential source for downloading the content, right? But then there's task sequences. And task sequences work the same way, except you have to enable things a little bit differently to make sure that systems hold on to the content and are able to offer it back up when they get done imaging. So let me go back to the two scenarios for imaging, right? So the steps that we provide in documentation make the assumption, I think inaccurately, that when you image a system or when you apply a task sequence to a system, imaging typically, you will want that system that has just imaged to act as a content source peer and be able to share its content with other systems that are in the same boundary group that will be imaging, right? And the steps that are provided in the documentation talk you through how to configure the task sequence to make that happen. But I think that's not the best assumption in the world. You instead may want to have a single system or a couple of systems that you've pre-identified as content source peers that you want to pre-provision the content on so that they can then serve up that content to peers that ask for that content, right? The way that, and I'll call this out as we go through, the way that the different configurations in the task sequence are documented will cause systems that are not flagged as content source peers to retain their content in an attempt to make them available to offer it to other peers, right? So I'll go through it, and maybe it'll make more sense as I do. So let's go through the requirements. So to do this, I have a task sequence created, and you'll see all this. It'll make a lot more sense when you see it live. So under operating systems, I have a task sequence created, and it's right here. It's basically install Windows 10 1703 peer caching. So a couple of things that are required to enable a task sequence for peer caching, to work with peer caching, right? So the first thing, use a download package content step. Now you can look at this task sequence real quick and see, I've actually built this. I don't ever want the image to actually work because I don't want to image my systems. I'm breaking out of that image. In fact, the sleep 30 seconds will actually error out, which is fine. It breaks out of the task sequence. But what I do want to do is pre-download the content for the task sequence, assuming the task sequence is going to run, into my task sequencing environment so it's available locally and I can just use it locally, right? So this download package content step will force the task sequence to download all content, in this case ahead of initiating execution. Now there's discussions about where you place this step. I've seen some people place it at the bottom, whatever, because really the download package content step in this case could be thought of as preparing the system to act as a peer cache because you're storing the content leveraged by the task sequence in the cache, whatever content you're wanting to use. In my case, I put it first just to illustrate and for the examples I'm doing, but you could put it at the bottom. And then you configure where you want to store that content. In this case, the content typically would be deleted after imaging is complete. Here we just say no, redirected, put that content in the client cache, right? So all of the content used by the task sequence and defined here will be stored in the client cache once that imaging process is finished, right? Again, a challenge here. Why? Because this assumes that every machine that is going to be imaged will be storing that content for potential use to serve to others. In other words, when you put this step in, it assumes that you're going to be leveraging this system as a super peer, as a content source peer. Otherwise, why would you store that content in the ConfigMgr client cache? Now, this step is not a specific step required for just peer caching. You can have this step turned on to just proactively download the content, and you could just say, don't do anything with it, whatever. Don't store it in the client cache, whatever. And then it just gets handled as normal. It just goes ahead and downloads it all ahead of time, right? So there's other reasons to use this. But if you're preparing the system to act as a content source peer, you definitely want to download the content used in the task sequence and specified here so that it does get stored in the client cache. Hopefully that makes sense, right? Okay, now there's a couple of other things that we need to factor in to enable storing or running this as from a peer, right? So where you have the collection of systems that you're deploying to, let me go up here to Assets and Compliance. So under Device Collections, you actually see that I have two device collections. This one is a collection that uniquely contains all of my systems that have been enabled to be super peers or content source peers, right? That way I can deploy things ahead of time to them. I can use that to seed the content into those systems, whatever. This collection is one that I'm going to deploy to, right, for production deployments. Well, so you saw the download package content for task sequence. There's also a requirement that you enable at least a couple of more variables, right? So under collection variables here, I have two variables, SMSTS peer download, right? So this enables the task sequence to be able to download from peers and factor peers in instead of just factoring in traditional distribution points. So you would configure this value, set it to true. You want this value available ahead of task sequence execution, which is why we store it as a collection variable, right? Now you can do a machine variable too, but just a collection variable here. SMSTS preserve content. Now, this is another one that I think is a little bit misleading. The documentation says set this to true to require preserving the content on the system that runs the task sequence. Well, that's great if in fact you want that system to act as a content source peer after the image is complete or after that content's downloaded, whatever. If you don't, In fact, if you're running this on a system that does not have itself enabled as a super peer, content source peer, and you have this enabled, you're going to preserve the content, but it doesn't matter because you're not going to be able to serve it to anyone else because you're not a content source peer, right? And then there's an optional variable called SMSTS peer require port, just like in the client settings where you can specify a port to use or ports to use that are different than the default. You can specify that with these variables too. This is optional and up to you if you want to use it, right? Okay. Now, before I go forward, there's sometimes you'll see talked about in some of the articles that are out there, peer caching right alongside an option that is there to pre-download content, right? So I'm going to talk about one option, and I'll show you actually two places where you can pre-download content. But know that the pre-downloading content is not a requirement for peer caching to work. It might be a convenience, which is why sometimes they're talked about together, but it's not a requirement, okay? So this thing that I'm going to show you is more a convenience rather than a requirement when you do certain types of image deployment and so forth. So let me go back to the software library node. And now this time I'm going to go to my operating system upgrade packages. So uniquely, whenever you're doing Windows 10 management with a task sequence, you might be running an upgrade from one version of Windows 10 to the next. And there are some challenges that you might have. One of them, if you use language packs, you can factor that into the task sequence. It's a real, I wouldn't say it's a real challenge. It's a decent amount of work to actually do that. It's not hard work, but it's a kind of like driver package and so forth. So there was a ability added specifically to the operating system update content for imaging upgrade packages to be able to specify in data source language pack information so that you can pre-download this content whenever this upgrade package is used on the system so that you have the right language pack from the beginning, and when the setup routine runs, it just has the right language pack and injects that as you go into the process, right? Again, I show that to you. I'll show you one other pre-download thing in just a minute. Pre-download and peer caching are not tied at the hip. They are a convenience, right, to talk about sometimes together. So that said, let me pull this out of the environment. That is configuring ConfigMgr peer caching. Now, to the fun part, let's go into the demo of actually seeing ConfigMgr peer caching in action. So to kind of help illustrate, I think in pictures, to kind of help illustrate how this is going to work, let me describe it here. So I have my boundary group offset in this rectangle, darker blue. And so I have my standard systems that are not enabled to be a content source peer or a super peer right here, right? And then I have the one system that I'm identifying as a content source peer, super peer, right here. I've made it larger just to kind of stand it off as being that one system in this boundary group configuration enabled. Now you could have 2 systems, 3 systems, whatever you would like to do. In my lab, I just chose one. So when you deploy content, and this could be any content at all, this is kind of how it works. Assuming this machine gets or whenever this machine gets the policy for that content, you might want to pre-deploy it. We'll talk about an example of that in a minute. It's going to make a request. Content source peer is going to request content from the management point like always. The management point will return the content locations, and this time the content is not on a content source peer in the same boundary group, so only available distribution points are returned, right? So then the client gets that, goes and retrieves the content from an available distribution point it picks from the list, and then once we have the content, kind of part of this step, once the content is downloaded, since the ability for this thing to be a super peer or a content source peer is enabled, the client is going to send a notification to the management point here, which then creates a record or forwards it into the primary site and creates a record in the database that the content source peer is now also able to serve the content, right? Now, you'll see how this works in a minute, but I'll just say right now, this is done by state message, right? So now this system content is cached on the content source peer. Now we have other systems in the same boundary group. So one of these systems will go up, now the red line, to the management point. Non-content source peers request the content. The management point now returns content locations. The response now includes available distribution points and content source peers, right? So then we're back to the client. The client randomly chooses from available distribution point locations and retrieves the content, right? So that's how it works. And again, I mentioned earlier, when you have peer caching enabled for a boundary group, then systems in that boundary group can go try to get, or will go try to get the content locations the normal way. They will get returned the traditional distribution point and the peer in their boundary group that has the content. Then it is a random selection from that point where they go, right? Could be a traditional distribution point, could be locally, right? Some more about that in a minute. Okay, so let's get into the demo part. I want to break this down into a couple. First, I want to talk about task sequencing, and then I want to talk about standard deployment, and then we'll clean up the environment and so forth. So let's go back into the lab. So here's my site server, okay? Let's go back up to assets and compliance. Assets and compliance. And so I showed you the collection that I've created. Let's go back and do it again. Here's a collection that I've created to specifically identify the content source peers that are available in the environment. This is not a per boundary group thing yet. This is taking all of the boundary groups I might have configured, pulling out the right content source peers for each boundary group and placing them in the same collection so that we can target client settings here to enable downloading from our, or storing the content locally. So if I show my members, you'll see that I have one member, and it's a Windows 10 system. Now, this is a Windows 10 system just because that's what I did. You can have any supported client act as a content source peer. It doesn't have to be Windows 10. All right, and then I have my collection where I will do all of my deployments, and this happens to be 2 Windows 7 machines that I have in my environment for testing, okay? So the one collection to identify the content source peers that I can enable for being a super peer or sharing their content. Then I have a deployment collection, right? Making sure that at least one of the systems in my boundary group is part of my content source peer collection, so it's being enabled for content. Now, I kind of talked you through the variables just a minute ago, but let me show them to you again. So I have, this is an imaging demo, so I have enabled my variables on my deployment collection, this one for systems that are already ConfigMgr clients, and maybe I'm going to re-image them or whatever from Software Center. So I have the collection variables here, okay? I also put them in all unknown computers if I'm wanting to leverage unknown computer support for bare metal imaging, then I can put them in my collection variables as well, right? So when the systems come in as bare metal and request detail from the site and so on, they'll get the collection variables that way. Since they're existing ConfigMgr clients, they'll get collection variables that way in the other collection and so forth. So we are ready to roll. So I have this task sequence that I've configured. Okay, let's go back to it. Oops, here. I have this task sequence that I've configured. Again, as a reminder, I have specifically built it so it doesn't image anything because I don't want to image machines in my environment, but I do want to take it far enough to show kind of how this works. And to make this work, I've created a deployment to my collections. Now, if you look at my deployments, you'll see that I have a few deployments, right? Why do I have 3? Well, for a few reasons. Here, you'll see that I have my deployment to the collection of systems that have been identified to be caching source peers, super peers, right? Why do I deploy this specifically to those machines? Because I might not want to image those systems. In fact, I probably don't. But I absolutely want to provision those systems with content to serve other machines when they image and happen to be in the same boundary group, whether those machines are existing config manager clients or brand new bare metal builds coming into the environment that happen to have an IP or an AD site or something that lines it up with this particular boundary group where my content source peer is providing service. So that's why I have this one to seed the content, these two to support the actual imaging operations for systems in those collections that need imaging. So we'll start here. So let me go to properties here. And I told you that there, let me see if I can find it. Where is it? So whenever you set up the deployment, it's not on there where I can show you properties. When you set up the deployment, one of the first questions you're going to get asked, so I'll just put in a dummy collection because I'm not going to save this. Let's just do that. Right here, pre-download content for this task sequence, right? Now, this is that second example of the pre-download stuff that I was mentioning is a convenience, not a pure cache requirement, okay? So if you don't enable pre-download content for this task sequence, that's great. The content will get there whenever the task sequence runs and not before, based on the being manually kicked off in Software Center or the required time or whatever it is, right? That's fine. The content will get downloaded. It will be offered up, assuming that machine that downloaded the content is a super peer or a content source peer. It'll be offered up once that content is there. But in my environment, I have my defined super peers, my content source peers. And I probably don't want those systems imaged. I may not want those systems imaged, right? I may, and that's fine. And there's ways to support that and to keep them in a super peer status after they're imaged and so on. If I want to pre-provision the content to my super peers, I'm just going to keep saying super peers instead of the other longer name, content source peer, as we go forward. If I want to pre-provision content to my super peer, then I just need to tell it pre-download the content for this task sequence as a part of this. And that's what I did for my other deployment. Now, if you go into the deployment, if you go into the deployment here, you will see this is not a required deployment, okay? So it is available. There is a facility in ConfigMgr whenever it sees a deployment that's available and there's a flag to say pre-deploy this content or pre-download this content, it's going to go ahead and pre-download the content, right? So historically speaking, the only time the ConfigMgr client would pre-download content is if the deployment, whatever it was, comes down required with a date sometime in the future or now, right? If it's a future required deployment, the system will go ahead and start downloading the content right away so it's in the cache and available, okay? This is a departure from that. This is an available deployment, and you can still set the flag to pre-deploy or pre-download the content, and as soon as that thing comes in, it's going to see that that is available and start to download it. In fact, I'm going to go ahead, just since we're here with the magic of video, I'm going to go ahead and delete this and then go and show you live, kind of how this works on my system for pre-downloading. So let me go ahead and delete this deployment, and then I'll clean up my Windows 10 system, and then we'll recreate the deployment and watch it come in. Okay, so I have cleaned up that deployment. You can see my Windows 10 system, operating systems. I do have one task sequence here that's not related to this. There's the other task sequence I just deleted. This is cleaned up, it's ready to go. So I'm going to go ahead and move this out and go ahead and recreate the deployment so you'll see it live right here. All right, so deploy. And I'm going to pre-download. I'm going to select my collection for pre-downloading right here, or pre-deploying right here. Hit OK. And click Next. It's available, only Config Manager clients, that's fine. No schedule, since it's available and not required. I'm going to go ahead and just click things that I standardly will click. Click Next, distribution points. Now, this is important to understand. If you select this, it's going to disable the purposes for what we're after here. It's going to disable peer caching and some of those things that we're trying to do. So leave this enabled. I'll turn this on. And I always select here and here just out of habit. This has absolutely no impact on peer caching at all. This is to support branch cache. If I don't even turn this on, then I'm still going to be able, in fact, let me just, well, this is for pre-provisioning, but if I don't turn this on, it's still going to allow peer caching to work and serve content. So I'll click Next, and then Finish, and off we go. So we're creating that deployment. Let me pull this back out, and I'll replace it with my Windows 10 machine. Okay, so you see I have a couple of windows open. I have my logs folder. I have my CCM cache, which is currently empty. And then I have this so I can look at my task sequence folder when I want to, but not yet. So I'm going to go ahead and pull up the Config Manager client applet, go into Actions, and go into Machine Policies and kick that to Run. And then hopefully we'll see this come up in just a second with the task sequence. Let's refresh it a couple of times. So I'm going to pause the video when it comes up. Shouldn't be a matter of a couple of minutes. We'll come back. And as quick as that, it'll pop right on in. So I haven't done anything except for get the policy to come down. It's here. And I'm going to now go into my logs, and we'll see Execution Manager, in this case, right here, should already know that we're supposed to download that content because it's set to pre-download right here, right? So you can see the time, 3:48 matches the time on the client, enabled for pre-download true. And so it's going to take just a couple of seconds, and it's going to start the pre-download process. So I'll pause the video, and we'll come back once that happens. All right, so we have executed this. It failed, as I told you it would, because all I care about is downloading the content into the cache. I have the 3 files that I need. This is my Config Manager client. Here's my boot media, and that's just notifying me of something else. And then here is my just install Wim for the image. So all 3 pieces of content are in the cache. I could go through the CAS log, the data transfer service, and the content transfer manager and trace all of this. Don't want to do that, but you see it's now here. And so now that this system that has been enabled to be a super peer has the content, that process that needs to happen to notify the management point and ultimately record in the database that this is a source for retrieving this content has happened. So I'll show you the reverse process of this in a minute. But the way this works is that as soon as this client gets the content downloaded, it will send up a state message to the management point, and then the management point forwards that on to the site server. It's a high-speed state message to say this content is available and now can be hosted and delivered, or is hosted from and can be delivered from the super peer, right? So we could trace that through. You'll see the state messages happening, right? But it's easier to show you kind of the reverse process when you clean it up. So I'll wait and show you the state message thing whenever we clean the environment up. But either way, this is now here, and the content is available in the environment. Right now, I want to show you now what it looks like for getting it from the super peer, or now that it is on a super peer, how the client will go ahead and retrieve that content. So let me take this out of the demo window and instead pull in my Windows 7 machine here. So this is my Windows 7 machine, and I have Software Center on it as well. Software Center. And so it has the same deployment for the same task sequence that will fail the same way, because again, I don't want to image this one right here. Okay. it does not have cache, or it does not have the content in the cache. It's clean. So I need to go retrieve that content. So I'm just going to retry this and install. And it's going to go do its thing and starting to download. So you see it's installing, and then it should start to download the content in just a minute. So right here, once we see it move to the download step, we'll go look at the files. In fact, let me go ahead and pull up the logs. Here we go. So it's downloading the content, downloading package content. Let's immediately, well, I went to the wrong place. Here, let's go to Windows, CCM, logs. Here we go. Now we'll open this log, and I will immediately pause it, right? So you see it's downloading the content. And so that we can tuck that down here somewhere. It's running. Let me maximize this. And so hopefully things will work the way that I anticipate they did. All right, so it did a location request. It got location here, adding peer content server. You can see that it gets both locations. So this is the primary or the traditional distribution point, and this is the content source peer, the super peer. It gets both. And so now that it gets both, it's going to start figuring out which one to use, and it's going to prioritize, where do we go? Down here. Where's the download starting? Let me just search for it so I can find it easier. Setting URL. So here's, it's selecting the peer location, and it's going to start downloading from the peer right here. So here we go, right? File setting, blah, blah, blah. And so we're downloading from the peer. So this task sequence is now coming from the peer, downloading all of the content into its cache, but it's doing it local. And this is taking a little bit of time as it sifts through it, but here's the first one that it got, and then it'll work through the rest, and so on, right? So we'll let that process. It'll take a second with this slower resource Windows 7 machine on my lab, VM server and so on. But you get the point, right? So I'll pull that back out. Oh, one thing that I forgot to mention. Let me put this back in. So if I go to my logs directory again. So one thing that's kind of interesting as a telltale, right, is you see, if I blow this up, we're right there where we can see it. This entry. So downloaded file from here, right? Notice it is the right server. It is my content source peer. This is the location that it's pulling from, so you know it's not a traditional DP. It is using a URL format, so this kind of tells you that the super peer, whenever it becomes a super peer, it's going to self-host the content in IIS. So I spent some time, I kind of gave up after a minute, didn't really follow it down. But you can actually navigate, you can try to navigate to this location. It will fail, or at least it did last time. So let's see, yeah, that failed, so I'm fine. It'll fail, but it won't fail as if it doesn't exist, right? There's a certificate error here that I wasn't able to get past. So I wanted to go to it. It wouldn't let me, couldn't really get past it. Didn't really spend the time to do it. But anyway, this kind of confirms to you that this system, when it becomes a super peer, is now providing content through IIS, through bits, right? And so since it is through bits, sometimes people ask, can I throttle content even though we're in the same boundary group? Can I throttle content? And the answer is this uses bits. So yes, you should be able to throttle content without any problem at all, right? But just FYI, that's kind of how it works. All right, so one other thing, I mentioned I tried to go looking for this in IIS on that super peer. I couldn't find it. So it doesn't actually show up. If you load the IIS tools on your super peer, it doesn't actually show up. So the only assumption I can make, and purely an assumption at this point, but it makes a lot of sense, is that somehow ConfigMgr is self-hosting with bits and not using IIS directly. But anyway, that's getting way off, too much off in the weeds, but it's just kind of interesting. Okay, so we've seen how that works. Now, let's go and deploy a traditional application. So I've already got a traditional application deployed, but let's kind of go through the same route, right? So there's nothing in the application itself that I have to turn on to enable it to work through peer caching, right? So I've simply got rich copy provisioned as an application and deployed. So here's rich copy. I have deployments of it. 2 deployments again, one to seed the content and one for the actual deployment. So if I pull this back out and pull my Windows 10 machine back in, or yeah, my Windows 10 machine, my super peer back in. So here it is. Again, you see that I have 3 pieces of content here. I'm going to go ahead and install rich copy, and it will download the content. Again, I could follow it through, but let me uninstall rich copy. Hang on a minute. Yeah, it's got to download the content. That's what I need it to do, is download it. Then I will reinstall it. As long as the content's in the cache. Great, let's install it again. Good. So I'm preloading it into my super peer so that I can then have it available to other systems around in my boundary group whenever they ask for it, right? Now, you do not have to pre-provision. Pre-provisioning is a step you can take to increase the efficiency of peer caching, and we'll talk about a scenario specifically like that in just a minute. But the content now is here. We could trace through and you can see it pulling from a traditional DP. Don't need to do that. This is standard content acquisition like we've done for years. But now let's pull in my Windows 7 machine, put it in the middle, and we'll go to Software Center here again, and we will provision rich copy. Okay, so it's deployed here just like it was to the other machine. It's available, so I'm going to click on it and select. Let's make sure it's not in the cache. Should not be at all. Windows, CCM cache. It is not. I recognize those two as being from the imaging, so I will install this. And it's going to go download. It downloaded quickly. It's installing. It should be in the cache at this stage, and it is. So now we can just go to our files, our logs, and see where it actually pulled it from. So I'm going to go to CAS. We'll go to a couple. So I'll go to CAS. And the first thing is you see that I was told that it could be obtained here on the traditional DP, or I actually get 2 entries for the same DP on my peer cache. Not sure exactly why, but nevertheless, here it is. So you see it's getting locations returned that include the peer cache now, because the peer cache has said, I have this content now, through, again, high-speed transmission of a state message. Now, let's go see where it actually pulled it from. So we can go to Content Transfer Manager and look. Data Transfer Service, sorry. I always get those two messed up. And we see that it actually is starting to pull it from, even though it has both the Windows 10 system and the traditional, it's selecting the traditional distribution point, and it's just pulling it from there, right? So that goes back to the point I made earlier. When you have peer caching turned on, it just gives an additional download source. It does not guarantee that download source. So in this case, it was going to our traditional distribution point. So I'm going to put an asterisk there, and I will come back to that in a minute. So let's kind of finish up this discussion in terms of showing how it works a little bit. Let's pull back in my Windows 10 system that is acting as a super peer, right? So I mentioned that I had the habit of just coming in here and selecting delete, right? Whenever I wanted to force the client to re-download some things. And I always knew that was not the right way to do it, but it always worked, right? Well, now, if I simply go in here and delete, I'm bypassing the process that is notifying the database that, in fact, the content is no longer here and can't be served from here. So I could be causing problems if clients try to use this super peer. So the right way to do it is either to use the SDK methods to clean things up, or to come in, let ConfigMgr clean itself up through its own cache maintenance, right? And that's a good point to make too. ConfigMgr takes care of its own cache based on size and deleting content and so forth. And when you enable the system as a super peer, it doesn't change any of that. The system still manages its own cache. What you're doing probably is increasing the cache size, which gives it more headroom to manage, but whenever the cache is full, it still has to manage things out, right? The process of managing its own cache and cleaning things up and so on, that will work and factor in the notifications back to the side in terms of what content's available on the peer and so forth. Another way to do it is just to go into the cache and go in and say delete files. Now this will delete all of them. And so you'll notice that these files will, well, they were supposed to go away. Here, configure settings, delete files. Why did that not work? That's interesting. Let me try to launch it again. I will get that to work. One moment. Okay, so that just worked. You saw it clean up, and trust me that it did just work. All I did was close and reopen the ConfigMgr client applet, so something was weird there. But to show what actually happens, go to the state message log and go to the bottom after you, here, this is why it's easier to show it to you this way, and you'll see that there's a state message right here that is created, topic type 7200, specifically telling you that the content has been removed from the cache. That is sent forward at a high priority to the site so that you know, so the site knows that it's been cleaned up. In fact, I probably was a little bit too quick on state message log. A little bit more as it sent it forward and so forth, right? The state report sent forward. Now, you can see this in the MP log. The MP relay agent is what transfers over the state messages. You can also see it if you capture the state message log. So I actually pulled in, I'm sorry, if you capture the state message on the site server, and you have to stop some services and do some things to do that. So I went ahead and captured one, and I'll show it to you here. So this is, I mean, it's not something you need to do, but just FYI, right? So I went ahead and opened this. Let me pull it up. There, open it with Notepad, and here we go. So this is the state message that was captured and would say to remove the content. And I can search in here for topic type 7200. I'll see it in here. I will see the specific detail about what's being removed and so forth right here, right? So it just shows you that state messaging is what does this. So I'm going to go ahead and pull that out of the way. Right. Okay, so what other things do we want to talk about while we're here? Well, actually, let me pull this back in, the site back in. Let me find my site server. Okay, here it is. So pull this back in. So the last thing, kind of walking through all of this, being able to keep tabs on how things work in the environment. So reporting, great place for all sorts of detail about how things are going, and peer caching is no different. If you just search for peer, you will find that there's 3 reports that will kind of tell you what's happening and why they're happening perhaps, and so on, right? Okay, so let's pull that out. So that's a demo. That's peer caching in action. Really simple concept, but just wanted to show you kind of how it works and how you can troubleshoot it and look at things yourself. So what about troubleshooting? What about tips and tricks? Well, I want to show you a couple of things here too. So first, in terms of troubleshooting, I've shown you some of the logs, right? There's client logs. So you can look at those entries that I showed you that have the branch cache $ in them and show that it's using a content source peer for its download location. You can see that in SMSTS log. You can see that in data transfer service. There's the 3, CAS, Content Transfer Manager, Data Transfer Service. You can see the state messages going back and forth to indicate that the content is now stored in the superpeer's cache or deleted from the superpeer's cache in state message log. Now, some of the state messaging, sometimes you'll see an SMSTS2, but it's a state message nonetheless. And for the management point, right, there are two entries that are interesting for the management point. In fact, I'll just pull my lab server back in so we can talk through it. This is my site server and also the management point. So if I pull up the logs here, I'll just go into the management point log specifically and look at MP logs. You'll have MP underscore location here. And there's, whenever we've looked at this historically, when clients make location requests, all they're doing historically is getting a stored procedure run that will go look at the traditional DPs, figure out which ones are available based on the details submitted in the location request, and send that back, right? That's done using the stored procedure MP get content DP info right here. Well, now that we've added in the ability to do peer caching and also the ability to have a cloud distribution point, we have a stored procedure to also factor in cloud DP availability if content's there, and also factor in superpeer information if there's a superpeer out there. So for the content location request, you're actually running 3 stored procedures. This is the one that will identify superpeers that have the content, right? There's another log on the MP that is involved in this, and it's the MP relay. As I mentioned, that's where the state messages are forwarded to the site that indicate either the content has been removed from the superpeer cache or added to the superpeer cache. And then on the site server, there's the state sys log you can look at to determine how things are going there. And if there's a state message problem, it's going to impact your superpeers as well, perhaps. So, be aware of that. Now, just kind of doing a little bit of touring of a couple of things that might be of interest. So in WMI, on the site server, you can connect and open up the SMS namespace and then the site namespace. And then there is a class called SMS WinPE peer caching config, peer cache config right here, right? Now, I'll talk about this class more in a minute. I just wanted to show you where it was for now, but this is where that's located. On the client, let me close that. On the client, let me pull the client back in, a client back in. I'm getting into window confusion here, just a minute. There we go, let me pull my client back in. So this is my Windows 10 client that is also a superpeer, and I'm going to browse to the desktop and launch WMI Explorer as admin again. There we go. All right, and this time I'm going to connect and go into the CCM namespace. All right, and go into policy, if I can get that to expand. Policy, come on. Machine, I don't know why, there we go, machine actual config. All right, and there is the CCM superpeer client configuration. So if you need to validate that the information that you've configured has made it down correctly, you can do that. You'll see whether it's enabled as a superpeer or not. You'll also see port information and so forth, all in this class, right? So back on the site server, pull this back out. So back on the site server, again, window confusion, there we go, site server. So in the database, again, database, just sharing this for knowledge information, look, don't touch kind of thing. If you're familiar at all with the database structure, you might think that our distribution points all would be in the same location, whether they're traditional distribution points or superpeers. And that's a good assumption. It's also not true, right? So if you were to go look in the traditional locations in the database for the DP information, like DP content info or whatever. Let's find an example. DP usage, DP status, notification, info, whatever. You wouldn't find anything about the super peer here, right? But if you go down to super peer, you'll see there's 4 tables that have information about super peer in them right here. These tables will tell you, for example, who your super peer clients are. All right, when this runs. So I have, this came back empty, that's interesting. Who actually has, let's try this one. Let's see, select top 1,000. Okay, so this is my super peer. I hit the wrong one, right? My one client that's a super peer. Who has my content? Which super peers have what content? I did this wrong thing again. There we go. I swear up there. Okay, good. So this will tell me what content is cached on my super peers, resource ID and so forth. Right? You can do more with the tables, but that's there. Just FYI from a here's how it works kind of perspective. Now, let me talk about a couple of scenarios, kind of under the tips and tricks idea. Let me talk about a couple of scenarios. I call them tips, right? So I showed you how this works so that whenever you have a client that is able to pull content from a traditional DP, but also has a super peer in its same boundary group with that content available, it will get a list that includes both the traditional client and the super peer, and then it will randomly pick between, okay? You may not want that. In fact, you may want to have the client go always to the super peer. So how do you achieve that? Well, so one idea would be just like you have seen in my lab, where I have a collection of the super peers and then a collection for standard deployment for everyone else in the environment. Could be that you would maybe have that deployment for the super peers configured to allow fallback or to allow it to fall back to distribution points that are not part of its boundary group. So say it a different way. It could be in this configuration you only have fallback distribution points, right? And on the deployment that you create to the collection with the super peers, you enable the fallback. Let me show you what I mean. I'm going to pull the lab in again real quick. Actually, let me find the lab so I can pull it in real quick. There it is. All right, cool. Let's put the lab in play again. So I have my ConfigMgr console, and the settings I'm talking about back to software library are here. Well, let me just use the task sequence since it's easy to show you. Task sequence, and then my deployment. Any deployment will do. I don't believe I configured this one this way, but let's look. So on the distribution point tab, when it comes up, yeah, so allow clients to go to a fallback, default site boundary group, distribution point. So it could be that in order to get the content out to your super peers, you use the deployment to the super peers and allow them to connect to the fallback distribution point, or in the way we're calling it these days, the default site boundary group, which contains the fallback distribution point. And then that deployment will go out, it will go to the super peers will run that deployment, they will have nowhere to be able to get the content except for the fallback, and so they will pull the content from the fallback. Well, now the super peer has that content, right? So when we send the main deployment, we just tell it, no, do not let it talk to remote distribution points, to our fallback distribution point, and the only option that it has at this stage is to get the content from the super peer. So in this scenario, you would have the content on a fallback distribution point, and you would have the content that is on your super peer. right? Your fallback distribution point would not be configured as part of any boundary group except for the default site boundary group, right? So no one could access it unless fallback were allowed. And so the content comes onto the super peers. Whenever others get the deployment, they can only go to the super peers because they're not allowed to go to fallback. And effectively, you are routing all of the production clients to their super peers to go ahead and get content. That's one scenario that's possible. So pull the lab back out. One other thing I want to share. I showed you the WMI path to the SMS_WinPE peer cache config class. That's a site server class. It's not a client class. So there are some changes added as part of 1702, where in certain conditions we will not offer up a super peer as a content source, even if it has content. So a couple of conditions that would do that. If the super peer is a system that's running on battery and it's in low battery mode, it won't be presented as an option for the content, right? If the CPU load on the super peer exceeds 80% at the time the content is requested, it won't be offered as a super peer. If the disk I/O has an average disk queue length of greater than 10, it will not be offered as a super peer as a content source. If there are no more available connections, such as in the case of workstations and a 20 connection limit, and that connection limit is exhausted, then the super peer won't be offered as a source for content lookup, right? So that kind of talks through what I wanted to share in terms of the peer caching that's available in ConfigMgr Current Branch, and really, really cool option. Again, I think something that, regardless of what solutions you use, third party or otherwise, is not a bad thing to have on in ConfigMgr, just in general. So we'll wrap the session here, and we will see you next time.